All right, so this should be recording. Let's take a look at these three equations. They are rational equations. We see fractions in the equation. We also see variables in the denominator. And whenever we see a variable in the denominator, we have to be concerned about division by zero. So we have to check our solution set for extraneous solutions. So our first step in these is generally to factor all the denominators. Um, so let's take a look at number one. We've got 3 over x plus 6. And in the second term, 1 over x minus 2. And on the right-hand side, we can factor this denominator to x plus 6 times x minus 2. Because we needed two numbers that multiply together to give us negative 12, but add together to give us positive 4. So now we look to get a common denominator in each term. We can see that the denominator we want is x plus 6 times x minus 2. So if we come over here to this first term and we multiply this term by the number 1, but we write the number 1 as x minus 2 divided by x minus 2, then because when you multiply fractions together, you just multiply straight across the numerator and straight across the denominator, we'll have the denominator that we want. And when we do the same thing with this second term, we see that it has a factor of x minus 2, and then it's missing a factor of x plus 6. So we multiply by the number 1, but we write the number 1 as x plus 6 over x plus 6. On the right-hand side, we have the denominator we want, so we don't do anything to this fraction. So now if we are to multiply every term, both sides of this equation, by this common denominator, all these denominators cancel. And what we have is just the operations here in the numerator, 3 times x minus 2, 1 times x plus 6 is equal to 4. Now, at some point, I probably should make the remark that I can't have in my solution set a negative 6, and I can't have in my solution set a positive 2, because there's no way that those two values could satisfy the original inequality, because they would have terms that are undefined. All right, so let's continue here and use the distributive property. This negative 6 and positive 6 cancel each other out. And we have that 4x is equal to 4. So we have x equals 1, and that's not one of the values that we have to be concerned about. So my solution set consists of just x equals 1. All right. Let's come in and take a look at number 2, and we're going to try to do it in the same way that we did number 1. We look here and we factor the denominator that's on the right. So on the left-hand side, the 6 over x plus 3, we don't do anything with that term. We have minus 5 over x minus 2. And on the right-hand side, this factors to two numbers that when multiplied together give us a negative 6, but yet when added give us a positive 1. 3 and negative 2 do the trick here. And so again, we need to get a common denominator of x plus 3, x minus 2. So in this first term, I multiply by the number 1. But I write the number 1 as x minus 2 over x minus 2. when the numerator and denominator are the same expression there, that simplifies to 1. So the same thing with this next term. It's missing a factor of x plus 3 in the denominator, so we multiply it by x plus 3 over x plus 3. On the right-hand side, that term has the denominator that we need, so we just leave it alone. So we can make the remark right now that if x were allowed to be a negative 3, that would cause us problems because we would have division by 0. If we find in the solution set that x is equal to 2, that'll cause us problems because that causes division by 0. So when we multiply both sides of this equation by this common denominator, all of the denominators cancel. You often hear the phrase that you've cleared the denominators. So now we apply the distributive property, and with this subtraction, make sure that you don't make any silly sign errors here. All right, so let's combine like terms. We've got 6x minus 5x is 1x, and the minus 12 minus 15 minus 27. If I add 27 to each side, I get that x is equal to 7. That's not one of the values that I have to be concerned about. So x equals 7 is my answer. It's in my only number in my solution set for number 2. All right, so let's take a look at number 3. And again, we want to approach it in the same way, and that's to factor all of the denominators. So on the left-hand side, we have 1 over x plus 2. On the right-hand side, this first term, this x squared minus 4 is a difference of perfect squares, and that factors to x plus 2 times x minus 2. Then we have minus 1 over x minus 2. So the x plus 2 times x minus 2 is the denominator we want for every fraction here, for each term. So on the left-hand side, this x plus 2 is missing a factor of x minus 2. So that's how we write the number 1 here, is x minus 2 over x minus 2. And on the first term on the right, this is the denominator we want, so we leave this fraction alone. And here we have x minus 2, and that's missing a factor of x plus 2. So if we now multiply every term, both sides of this equation, by this common denominator, it'll clear all of our denominators. All we'll have left is the operations in the numerator. So we have 1 times x minus 2, which is just x minus 2. We have 4 minus 1 times the quantity x plus 2. Now, it's important to recognize that you're subtracting here this binomial, not just a single term from this binomial, but the whole thing. You're subtracting both terms. So we have x minus 2 is equal to 4 minus x minus 2. X minus 2 here, and negative x plus 2. If we add x to each side, and if we add 2 to each side, we have that x is equal to 3. Now I forgot to write some remarks to myself to remember to um, go out -2 or +2 if they were solutions. And I think it's a wise idea to write that up there so that you don't lose focus of it and you don't forget when you come down here. But I had forgotten to write it up there. Sorry about that. So x equals 3 is the only member of my solution set for number 3. I hope that helps. If you have any questions, ask, and I'll talk to you later. Bye.